Hi, today let's check if a linked list is circular or not. So the core idea of checking if a linked list is circular is while traversing it. At some point we will come back to the head node again. So this is the most intuitive approach, and let's say we have this particular linked list, say 1, 2, 3, 4, 5, and this is head, and 5 is pointing to the first node. So this is a circular linked list because it does not end at null. The last node points back to the first node. So for traversing, we initialize temp to the second node. So we store the head node separately, then we start the traversal from head dot next and not from the head itself. So we keep moving temp until one of these two things happen. The first thing is temp becomes null. So when temp hits null, that is one condition, and the second condition is when temp come back to head. And let's say if temp come back to head, we know that the list is circular. If we reach null before coming back to head, then the linked list is not circular. So this approach works in big O of n time and big O of 1 space, and it's perfect when the problem guarantees no inner loop. So by inner loop I mean it only works when the circle connects back to the head. So if suppose the circle starts somewhere in the middle, it fails. Let's see with an example. So we have this particular linked list, say 1, 2, 3, 4, and 5. Head is pointing to the first node, and suppose the last node is pointing back to the third node. Okay, so what happens here is the temp keeps looping between 3, 4, 5, and it never reaches head. So the key thing to understand here is the head revisit approach only detects cycles that explicitly connect back to the head node. Alright, now let's quickly code this approach. We are given the head of a linked list, and we need to check whether the linked list is circular or not. As we already discussed, a linked list is called circular if the last node points back to the head and the list is not terminated by null. So I defined this function which takes head, and firstly what we gotta do is we need to check for an empty linked list scenario. So if not head, then we return true. Why are we returning true? So if the linked list is empty, we consider it circular by definition. So now let's initialize the pointer. So we have pointer initialized to the second node. So we store the head separately and we start the traversal from head dot next. Now let's traverse the list. While temp and temp not equals to head, temp will keep moving. So we keep moving the pointer forward until either we reach null or we come back to the head node again. So the final check will be return temp equals to head. So if temp becomes equals to head, the linked list is circular, otherwise it is not. Here in the driver code, I made two methods to give both circular and non-circular lists for our testing. Now let's go ahead and run the code. So in the first case, the last node points back to the head. So our traversal comes back to the head and hence the output is true. In the second case, traversal reaches null, so the list is not circular and hence the output is false. Remember that this approach works only because the problem guarantees that there is no inner loop. Next, we'll see a more general approach using slow and fast pointers that can handle this inner loops as well. So now let's look into the two pointer approach. So in this approach, we use two pointers, say slow and fast. Slow moves one step and fast moves two steps. If there is a cycle, they will eventually meet. Let's take this example, say 1, 2, 3, 4, 5, and 5 is pointing back to the first node again. Head will be pointing to the first. So in this process, slow pointer starts at head and fast pointer starts one step ahead. Now let's start the process. Slow moves here, fast moves two steps, slow moves one step, fast moves two steps, slow moves one step, and fast moves two steps. and slow moves one step, and fast moves two steps. So if slow and fast meet at any point, the linked list is circular. And in non-circular linked list, if fast or fast.next becomes null, the list is not circular. Therefore, the slow fast pointer approach works for all types of cycles, including the inner loops. Hence, it is a much safer interview solution. Now let's look at the coding part now. Alright, now let's implement the two-pointer solution to check whether a linked list is circular or not. This method works even if the cycle starts in the middle. We use two pointers, one is slow and one is fast. So slow moves one step at a time and fast moves two steps. So if there is a cycle, the concept is that they will eventually meet. So we are given the head of a linked list, and first let's handle the edge case. If not head, we return true. So why are we returning true? An empty linked list is considered circular by definition, so that's why we are returning true. Now let's initialize the pointers. Slow is at head and fast is at the second node, that is head dot next. Okay, now let's traverse the list while fast and fast dot next. So we continue traversal as long as fast and fast dot next are not null to avoid any accessing of invalid memory. Now we can check for a cycle. If slow is equals to fast, we return true. We return true. If slow and fast point to the same node, it means that a cycle exists. Now move the pointers. Slow is slow dot next and fast is fast dot next, since it has to move two steps. Now when there is no cycle found, we simply return false. If the loop ends without the pointer meeting, the linked list is not circular. The trick that we are doing here is based on the fact that in a circular linked list, fast eventually catches up with the slow, and in a non-circular linked list, fast reaches null, so no cycle exists. Now let's run the code. As we can see, we got the right output for our test cases, where the first one is circular and the second one is not. So this approach works for all types of cycles, which is why it is a preferred interview solution. Thanks for watching.